Welcome to Quantitative Aptitude session on numbers. In this part 2 video, we will see about divisibility. Let's get started. Divisibility by 2. A number is divisible by 2 if its unit digit is any one of 0, 2, 4, 6, 8. For example, let's consider the numeral 958746 and check the unit digit. The unit digit is 6. So that means this numeral is divisible by 2. Let's take another example. Consider the numeral 69855 and the unit digit is 5. That means it is not divisible by 2. So if a number is said to be divisible by 2, then that unit digit should be 0, 2, 4, 6, 8. Divisibility by 3. A number is divisible by 3 if the sum of its digits is divisible by 3. Let's take an example. Let's consider the numeral 592482. To find whether the given numeral is divisible or not, first we have to find the sum of the digits of the given numeral. So here the sum of the digits are 5 plus 9 plus 2 plus 4 plus 8 plus 2, which gives 30. That means 30 is divisible by 3. Therefore, the given numeral 592482 is also divisible by 3. Let's take another example. Let's consider the numeral 564329. This is not divisible by 3. So first we are finding the sum of the digits and the sum of the digits is 32, which is not divisible by 3. Therefore the given numeral 564329 is not divisible by 3. Divisibility by 4. A number is divisible by 4 if the number formed by the last two digits is divisible by 4. To find whether the given numeral is divisible by 4, first we have to find whether the number formed by the last two digits of the numeral is divisible by 4. If it is divisible by 4, then the given numeral is divisible by 4. If it is not, then the given numeral is not divisible by 4. Let's take an example. Let's consider the numeral 892648 and it is divisible by 4 because the number formed by the last two digits is 48. 48 is divisible by 4. Therefore, the given numeral is also divisible by 4. Let's take another example. Let's consider the numeral 749282 and this numeral is not divisible by 4 because the number formed by the last two digits is 82. 82 is not divisible by 4. Therefore, the given numeral is not divisible by 4. Divisibility by 5. A number is divisible by 5 if its unit digit is either 0 or 5. Therefore, to find whether a number is divisible by 5 or not, we have to check the unit digit. If the unit digit is either 0 or 5, then it is divisible by 5. Otherwise, it is not divisible by 5. Let's consider an example. Let's consider these two numerals 20820, 57855. In both the numerals, we can see that the unit digit is 0 or 5. Therefore, these numerals are divisible by 5. Let's take another example. 69857 is a numeral which is not divisible by 5 because it is not having the unit digit as 0 or 5. Divisibility by 6. A number is divisible by 6 if it is divisible by both 2 and 3. To check whether the given numeral is divisible by 6, first we have to check whether the given numeral is divisible by both 2 and 3. If it is divisible by both 2 and 3, then the given numeral is also divisible by 6. And in some cases, it will not be divisible by 2 or 3. Then that given numeral is not divisible by 6. It has to be divisible by both 2 and 3. Let's consider an example. Let's take the numeral 35256 and it is divisible by 2 because the unit digit is 6. If the unit digit is any one of 0, 2, 4, 6, 8, then that particular numeral is divisible by 2. So here it is divisible by 2. And let's check whether the given numeral is divisible by 3. To check whether the given numeral is divisible by 3, then we have to find the sum of the digits. The sum of the digits is 21, which is divisible by 3. Then the given numeral is divisible by 3. If it is divisible by both 2 and 3, then the given numeral is also divisible by 6. This is how we have to find the divisibility by 6. Divisibility by 8. A number is divisible by 8 if the number formed by the last 3 digits is divisible by 8. To check whether the given number is divisible by 8, first we have to check whether the number formed by the last 3 digits is divisible by 8. If it is divisible, then the given numeral is also divisible by 8. If the number formed by the last 3 digits is not divisible by 8, then the given numeral is not divisible by 8. Let's take an example. Let's consider the numeral 953360, and this is divisible by 8 because the number formed by the last 3 digits is 360 and 360 is divisible by 8. Therefore, the given numeral is also divisible by 8. Let's take another example 529418, and it is not divisible by 8. Why? Because the number formed by the last 3 digits is 418 and it is not divisible by 8. Therefore, the given numeral is not divisible by 8. Divisibility by 9. A number is divisible by 9 if the sum of its digits is divisible by 9. So to check whether the given numeral is divisible by 9, then first we have to find the sum of the digits. If the sum of the digits is divisible by 9, then the given numeral is also divisible by 9. This is same like the divisibility by 3 rule. Let's take an example. Let's consider the numeral 60732 and it is divisible by 9. Why? Because first we can find the sum of the digits, and the sum of the digits is 18 and 18 is divisible by 9. So the given numeral 60732 is also divisible by 9. Let's take another example. Here 68956. This numeral is not divisible by 9 because the sum of the digits is 34 and 34 is not divisible by 9. Therefore, the given numeral is not divisible by 9. This is how we have to find the divisibility by 9. Divisibility by 10. A number is divisible by 10 if it ends with 0. To find whether the number is divisible by 10, then first we have to check the unit digit. If the unit digit is 0, then it is divisible by 10. Otherwise, it is not divisible by 10. First, take the example 96410 and 10480. In both the numerals, we can see that the unit digit is 0. So, this is divisible by 10. And let's consider another example 96375. Here the unit digit is not 0. Here it is 5 and this given numeral is not divisible by 10. Divisibility by 11. A number is divisible by 11 if the difference of the sum of the digits at odd places and the sum of the digits at the even places is either 0 or a number divisible by 11. To find whether the given number is divisible by 11, first we have to find the difference of the sum of the digits at the odd places and the even places. That difference should be either 0 or it should be a number which is divisible by 11. Let's see that in action. Let's consider an example. So let's take the numeral 4832718 and this is divisible by 11. Let's see how. First we are finding the sum of the digits at the odd places. In odd places we have 8, 7 and 3 and 4. So the sum is 22. And at the even places we have 1, 2 and 8. And here the sum is 11. So we are taking the difference, that is 22 minus 11, which is 11. And the 11 should that difference should be either 0 or a number divisible by 11 to make the numeral divisibility by 11. Here we are having 11 and the 11 is also divisible by 11. Therefore, the given numeral 4832718 is also divisible by 11. This is how we have to calculate whether the given number is divisible by 11 or not. Divisibility by 12. A number is divisible by 12 if it is divisible by both 4 and 3. To find whether the given number is divisible by 12, then we have to check whether the given numeral is divisible by both 4 and 3. If it is divisible by both 4 and 3, then the given numeral is also divisible by 12. If it is not, then the given number is not divisible by 12. Let's take an example. Here we are taking the numeral 34632 and it is divisible by 4. So to check whether the given number is divisible by 4, first we have to check whether the number formed by the last two digits is divisible by 4. Here the last two digits is 32 and it is divisible by 4. Therefore, the given numeral is divisible by 4. Next, we have to find whether the given numeral is divisible by 3. So for that, we are finding the sum of the digits. And here in this case, the sum of the digits is 18. So which is divisible by 3. So in this case, the given numeral is divisible by both 4 and 3. Therefore, the given numeral 34632 is divisible by 12. Divisibility by 14. A number is divisible by 14 if it is divisible by both 2 and 7. So, to find whether the given numeral is divisible by 14, first we have to find whether the given number is divisible by both 2 and 7. If it is divisible by both 2 and 7, then the given numeral is also divisible by 14. Next, divisibility by 15. If a number is divisible by 15, if it is divisible by both 3 and 5. Similarly, to find whether the given numeral is divisible by 15, first we have to find whether the given numeral is divisible by both 3 and 5. If it is divisible, then the given numeral is divisible by 15. Otherwise, it is not divisible by 15. So for 14, we are considering 2 and 7 because 2 sevens are 14. And for 15, we are considering 3 and 5 because 3 fives are 15. This is how we have to find the divisibility. Divisibility by 16. A number is divisible by 16 if the number formed by the last 4 digits is divisible by 16. To find whether the number is divisible by 16, first we have to find the number formed by the last 4 digit is divisible by 16 or not. If it is divisible, then the given numeral is divisible by 16, and if it is not divisible, then the given numeral is not divisible by 16. Let's take an example. The given numeral is 7957536 and the number formed by the last 4 digit is 7536, which is divisible by 16. Therefore, the given numeral is also divisible by 16. Divisibility by 24. A number is divisible by 24 if it is divisible by both 3 and 8. So, to find whether the number is divisible by 24, then that given number should be divisible by both 3 and 8. Similarly, divisibility by 40. If your number is divisible by 40, it has to be divisible by both 5 and 8. Likewise, divisibility by 80. A number is divisible by 80, then if it is divisible by both 5 and 16. Till now we have seen the divisibility rules. Now let's start solving some of the problems in divisibility. Let's jump into the problem statement. Which of the following numbers is divisible by 3? They have given two options. One is 541326, 5967013. Out of it, we have to find which number is divisible by 3. So according to the rule of divisibility of 3, we have to find the sum of the digits is divisible by 3 or not. If it is divisible by 3, then the given number is divisible by 3. If it is not, then the given number is not divisible by 3. Let's see the solution. Let's consider the option A. The numeral is 541326. We are finding sum of the digits. So 5 plus 4 plus 1 plus 3 plus 2 plus 6, which is 21. 21 is divisible by 3. Therefore, the given numeral is divisible by 3. Let's work on the second option. The given numeral is 5967013. And here also we are finding the sum of the digits. The sum is 31, which is not divisible by 3. So clearly we can see the first option is divisible by 3. Hence the sum of the digits is divisible by 3. Therefore option A is correct. Let's jump into the next problem. What least value must be assigned to star so that the number 197 star 5462 is divisible by 9? So from the problem statement, we can clearly understand that they have given a numeral which is 197 star 5462 with a missing digit star, and we have to find the star. That means we have to find that missing digit so that the given number must be divisible by 9 and that missing digit should be the least value. So let's get into the solution. So I'm considering the missing digit as x. So for if to find whether the given numeral is divisible by 9, first we have to find the sum of the digits in that numeral. The sum of the digits is 197 plus x plus 5 plus 4 plus 6 plus 2, which is 34 plus x. So the sum of the digits should be divisible by 9 so that the given numeral is also divisible by 9. So first we can try to assign some of the values to the missing digit, which is x. So if you are assigning 0, then that means we will be getting 34. 34 is not divisible by 9. Therefore 0 is not the correct answer. And we are assigning 1. If you are assigning 1, we will get 35. 35 is also not divisible by 9. Therefore, the given numeral will not be divisible by 9. And then we will try to assign 2. If you are assigning 2, we will get 36. Therefore, we have to check whether the 36 is divisible by 9. Yes, 36 is divisible by 9, so that the given numeral is divisible by 9. Therefore, the least value is 2. So in place of star, we have to replace 2. This is the answer. Let's move on to the next problem. Which digit should come in the place of star and dollar if the number 62684 star dollar is divisible by both 8 and 5? So they have given a numeral with two missing digits. One is star and the another one is dollar. We have to find those two missing digits so that the given numeral is divisible by both 8 and 5. Let's see the solution. So I'm considering the missing digit star as an x and the dollar as y. First, we will see about the rule of divisibility by 5. If the number is divisible by 5, then its unit digit should be either 0 or 5. So, y must be replaced by either 0 or 5. So, in place of y or in place of dollar, we can say we should replace either 0 or 5. Let's think about 5. If we are replacing y by 5, then we will get 4x and 5. At the unit place, we are having 5. So it will not be divisible by 8. So we will see the divisibility rule by 8. So according to the rule of divisibility by 8, if a given numeral should be divisible by 8, then the number formed by the last three digits should be divisible by 8. If the unit digit is 8, then the given number will not be divisible. If the unit digit is 5, then the given number will not be divisible by 8. Therefore, definitely we should not replace 5 in place of y. So clearly we can say in place of y, we have to replace 0. And we have to work on the divisibility by 8. So the number formed by the last three digits is 4, x and 0. So we have to replace some of the values for x. If we are replacing 1, we will be getting 410, which is not divisible by 8. So 1 is not the answer. And if we are replacing 2 by x, and we will be getting 420, which is also not divisible by 8, and so 2 is not the answer. If we are replacing x by 3, we will get 430, which is also not divisible by 8. So we should not replace 3 in place of x. If we are replacing 4 in place of x, we will get 440. It will be divisible by 8. 440 is divisible by 8. Hence, we have to replace x by 4. So we can say in place of star, we are replacing 4. And in place of dollar, we are replacing 0. So this is the answer. Let's move on to the next problem. Show that 4832718 is divisible by 11. So just remember the divisibility by 11 rule. If a given number should be divisible by 11, then the difference of the sum of the digits at the odd place and the sum of the digits at the even place must be divisible by 11, must be a number which will be divisible by 11, or it should be a 0. So let's move on to the solution. We are taking the given numeral and we have to find the difference between the sum of the digits at the odd places and sum of the digits at the even places. So in the odd places, we are having 8, 7, 3 and 4. And at the even places, we are having 1, 2 and 8. So on taking the difference, we are getting 11. So the 11 is divisible by 11. Therefore, the given numeral is divisible by 11. Let's move on to the next problem. What least number must be added to 3000 to obtain a number exactly divisible by 19? So we have to find the least number which has to be added to the numeral 3000 so that the result number should be divisible by 19. Let's move on to the solution. So first we are taking the given numeral 3000 and we are dividing the 3000 by 19. So on dividing 3000 by 19, we are getting 17 as a remainder. So we can easily find the least number which has to be added to the given numeral. So for that we are taking the difference of the divisibility number, which is 19, and the remainder. So 19 minus 17, which is 2. So the number to be added here is 2, and this is the least number. Let's see the next problem. Find the smallest number of 6 digits which is exactly divisible by 111. So we have to find the smallest 6 digit number which is divisible by 111. So first we are taking a 6 digit number which is 1 lakh, and we are dividing this 1 lakh by 111, which is the divisibility number, so that we are getting 100 as a remainder. So we have to find which is the number we have to add to the given numeral. Like here the given numeral is 1 lakh. So for that we are subtracting the 111 and 1000 and 100. For that we have to find the difference between this divisibility number and the remainder. So here we are taking the difference of 111 and 100, so that we are getting 11. So the 11 must be added to the given numeral, which is 1 lakh. So adding 11 to 1 lakh, we are getting 1 lakh and 11. So this is the smallest 6 digit number which is exactly divisible by 111. Till now we have solved some of the example problems, and in this video also I have 5 exercise problems for you. Please try to solve all these problems, and we will see the solution in the next video. And the first problem is, which of the following numbers is exactly divisible by 11? So they have given 4 options. Out of these 4 options, you have to find the number which is exactly divisible by 11. Just think about the divisibility by 11 rule and try to solve it. And the second problem is, which of the following numbers is exactly divisible by 24? Again, they have given 4 options. Out of these 4 options, you have to find the number which is exactly divisible by 24. Just think about the divisibility by 24 rule and try to solve it. And the third problem is, 6897 is divisible by 11 only, 19 only, both 11 and 19, and neither 11 nor 19. And the fourth problem is, the smallest number that must be added to the given numeral, which is 803642, in order to obtain a multiple of 11. And the options are 1, 4, 7, 9. Just think about divisibility by 11 rule and try to solve this problem. And the final problem is, the smallest number of 5 digits which is exactly divisible by 476. So they have given 4 options. Please try to solve all these 5 problems, and we will see the solution in the upcoming video. In the part 1 video of quantitative aptitude on numbers, we have discussed about place value, face value, and types of numbers. If you want to check that video, please watch that video. In that video, I have given 2 exercise problems for you. Let's discuss the solution of the 2 problems. The first problem is, the smallest 3-digit prime number is. Options are 103, 107, 109, and none of this. So for this, we have to consider from the smallest 3-digit number. So the smallest 3-digit number is 100. You know, this 100 is divisible by 2, so it is not a prime number. Then we are taking 101. So 101 is not divisible by any of the given numbers and any other numbers, so it is a prime number. So option, we don't have 101 in the options. That means we have to select this none of this, and option D is the answer. Let's see the next problem. Which of the following is not a prime number? Options are 241, 337, 391, and 571. Out of this, we have to find which is not a prime number. We know that for a number greater than 100, and to find whether the given number is prime number or not, first we have to find the closest number to the square root of the given number. For example, first I am considering 241. The closest square root number is 16, and we have to list the prime numbers which are less than 16. So the prime numbers less than 16 are 2, 3, 5, 7, 11 and 13. And we have to find whether 241 is getting divisible by any of the listed prime numbers. So 241 is not divisible by any of them and it is a prime number. So this is not a correct option. Next I am taking 337. Here also I am taking the closest square root value. For 337 the closest square root value is 19. Then we have to list the prime numbers which are less than 19. And the prime numbers are 2, 3, 5, 7, 11, 13 and 17. Then we have to find whether 337 is getting divisible by the listed prime numbers. So 337 is not divisible by any of the given prime numbers, so that it is the prime number. So the option B is also not correct. Next we are considering 391. The closest square root value is 20. And here also we are listing the prime numbers which are less than 20, which are 2, 3, 5, 7, 11, 13, 17 and 19. Next we have to find whether 391 is getting divisible by any of the listed prime numbers. Here we know that 391 is divisible by 17, so that the given number is not a prime number. If it is not divisible by any of the listed prime numbers, then the given number is a prime number. If it is getting divisible by at least any one of the given number, then also it is not a prime number. So we know that 391 is not a prime number. And we are checking the last option also. Here the closest value is 24 and these are all the prime numbers which are less than 24, and we are finding whether it is getting divisible by any of them. It is not getting divisible by any of the listed prime numbers, so it is a prime number. So the option C is correct, which is 391. If you found this video helpful, please like, share and comment this video. If you want to stay up to date with our latest content, please subscribe to my channel, Spider Tech Hub. Thank you.